Hello and welcome to the F.L.A.G guys, F.L.A.G Logistical Automation Groundwork guys, our Capstone Expo video for spring 2025, the one that will be on April 22nd. First, I'm going to walk you through some introductions of who's on the team. So we've got 4 mechanical engineers, and then we got 1 material science engineer. From left to right, we've got Mark Fivette, Benjamin Guarno, which is me, Ezra Kleinecht, Graham Tokars, and Micah Rowland. So first I'm going to run you through some important nomenclature. So TPF is going to be the shortening of toothpick flag, CV will be computer vision, OSHA will be occupational safety and health administration, CAD will be computer assisted design, BOM will be bill of materials. Also, customer design requirements will be qualitative design goals. Design specifications will be specified quantities, dimensions, thresholds, and properties. The design objective will be quantities to be optimized. Design analysis will be engineering analysis of system to determine required component properties. Component selection will be using the results from design analysis to select the best materials, manufacturing process, and supplier of component. And this is our agenda. So we've got design context and development, we've got software overview, we've got a system analysis, we've got an engineering analysis, current product, and future working conclusions. So first, let's get into the design context. An introduction and background into this project is that we've got F.L.A.G Co., our sponsor. It's a toothpick flag manufacturing company that produces about 70,000 customized toothpick flags per year. These are currently assembled, inspected, and packaged by hand, as seen on the right in Figure 1. A previous team has successfully designed an assembly device but did not have accompanying quality control methods. That's where we come in. We're going to be doing some quality control inspection to make it automated, to reduce the slow and efficient and human error quality control that exists right now. We're also going to be decreasing the reliance on human labor costs. So our objective statement is to develop an automated toothpick flag inspection and quality control system to minimize reliance on human labor, reducing manufacturing costs and improving efficiency while maintaining product quality. Customer requirements are to inspect and sort toothpick flags, removing the defective ones with 95% accuracy or higher. And we're going to be processing 11 of those per minute, which matches the automated assembly mechanism. And we're going to keep the cost under $1,000 per unit and be able to be placed on the tabletop. This is the previous team's design. This is assembling once again, and it will be interfacing with our quality control mechanism. Assembled toothpick flags will be received directly from this assembler. Our generalized design from the concept was to create a general model with open parameters that we could adjust as analysis improves. The 3D model improves the concept by condensing and consolidating. For the software overview, we've got some computer vision and AI image classification. So the classification models, we are using OpenCV to read the images and convert them to numerical data. We've got NumPy, which does the performing of the data manipulation, and then we've got TensorFlow Lite, which performs the classification. Essentially, what the image classification AI will do is look at a flag, decide if it's good or bad, and then output the label of good or bad, so we know whether to sort it and reject it, or sort it and say, yeah, this one's good to go. So we're going to be doing that with sample images for good and bad flags. There's going to be a very high number of training images needed to have the best quality recognition. And that's what the quality assessment is going to be doing. So for system analysis, we've got a lot of environmental considerations. We want to reduce the amount of impact on the environment that our system has. And we want high lifespan materials to minimize waste output. We also want to minimize all hazards and contamination of food-safe toothpick flags. So we're going to reduce the amount of human intervention as well as limiting the force of the conveyor belt and complying with OSHA regulations. This is our final CAD model. On the left, it's a rendered, and on the right, it is the dimensionalized CAD model. And this is a quick deformation of the frame. It's greatly exaggerated, but it's actually really never going to reach this. So that's a great point. Here's some of our analysis that we took and our cost-saving analysis. So the total cost will be $745, and we'll save up to $7,200 per year. So we were able to design a fully automated toothpick flag inspection and sorting system while greatly reducing reliance on human labor and improving efficiency. It complies with customer specifications including cost, size, and length inspection. In the future, full-scale prototyping and testing, as well as integration with the toothpick flag assembly mechanism will take place.